I'll talk to you about the philosophy behind the, are we up? Okay, there we go. Behind the framework and, or behind the test framework and why it's, sorry, well, jet lag still. But why I think it really can be used in a lot of different projects besides just web programming. Okay, so this is about it's about functional testing, but first I'm going to tell you a little story. How many of you have heard of this book? Just to get some rough idea here. Okay, a few of you. I think this is a pretty important book. It's been a New York Times bestseller, as you see on the top here. It's called The Lean Startup. And the idea behind it is taking agile testing methodologies and applying them to software products. So most agile development is often sort of custom code for a specific client you can meet with. You ship code every month or every few weeks. You meet with a client, talk about what they like, what they don't like, and continue to iterate. What the author here describes is sort of taking the same process for a larger, and applying it to a larger market, where you have one software product and trying to learn about the market and shipping code to individual customers and test customers, and really emphasizes learning about customers and about your market in a very iterative fashion, and really values knowledge. So this talk is partly going to be a critique of this book, so I'll try to represent it as best as I can. And the reason I feel qualified to critique this is I'll tell you a little story about what I was doing before I was doing Erlang. When I was 22, shortly after graduating from college, I went to work for Amazon.com as an operational excellence engineer, which meant that if something in the search service went down, I would find out about it pretty quickly. So I was on the team that wore pagers. So when somebody searches for red pants and no red pants come up, one of us would know very quickly. Service was all written in C++, not in Erlang, so it went down more than I would have liked. Anyway, so I was living in Palo Alto, and I don't know, how many of you lived in Palo Alto or Menlo Park or in Silicon Valley? You have? Okay. It's a great place to live if you're 22 years old and only care about working and watching other people count their money. With these sorts of places there are to live as a sort of a starting salary, there's a type of abode native to Silicon Valley called the Programmer Shack, which is usually a converted garage or a converted tool shed or something of that manner that has a tiny little bed because the rents are all ridiculous out there. So anyway, so I was living in one of these little shacks, this converted garage, and it was one weekend while I was on call, and I think the night before there had been some outage in Europe, so I had been up all night trying to fix Amazon servers, and I get a knock on the door, which I was not expecting. So I open the door, I'm all groggy, and this guy I'd never seen before introduced himself. He said, "Hey, I'm your new neighbor," because I was in this converted garage. There's like a main house where this family could live, and then there's the little shack where the programmer lives. And I said, "Okay." He said, "Well, I got a couple questions for you." I'm like, "All right." He says, "Oh, we want to know about the recycling situation." I said, "Well, there's a recycling bin right there." And he says, "Okay." He says, "My other question is, has this house been tented?" I said, "What?" He said, "You didn't see like a big blue and white tent over the entire house?" I said, "No." He's like, "Are you sure?" So apparently, this is a thing in California. If you have termites and need to exterminate them, you put a big tent over the house and then spray the bejesus out of the insides. So apparently he had smelled something on the inside of the house shortly after renting it and was convinced it had been tented and they hadn't gotten rid of the exterminator smell or something. Anyway, I thought it was a weird little interaction that we had, but we kept talking a little bit. And he was asking me what I did, so I told him about working at Amazon. I told him, well, I'm a programmer, but I got this job where I wear this pager, which is why I'm so tired all the time. He said, well, do you program PHP? I'm like, yeah, I've done some PHP. Well, do you program Perl? Like, yeah, I do Perl. So I was like, here, just take my resume, go away. So he comes back a few days later. So he actually works with this 3D avatar chat company in Palo Alto. And 3D avatar chat, for those of you who don't know, is a service where you go on a website and you can pick out like your hair and like a shirt for yourself and your breast size and some pants. And then you go into a 3D chat environment and talk to other people who have picked out their own avatars for themselves, and you type messages to each other. So that was their product. And he asked me if I wanted to go interview for them as a software engineer. And since it was not as an operational excellence engineer, it sounded like a great opportunity to me. So I went over there, and Palo Alto is a really interesting place because everybody and everything is connected. So this office, as chance would have it, is on a street, and right across the street was my current office, and right on the 4th floor of that street was my boss's office. So if I wanted to go interview at this new place, I couldn't do so without actually being in the line of sight of my current supervisor. So I had to very carefully plan when I would go interview. I'd figured out when my boss's meetings were, and I always enjoy. People talk a lot about how government workers always take their vacations on Mondays and Fridays, or it's like 50% of the vacation, sick days, are on Mondays. In Silicon Valley, it's most of the vacation, or most of the sick days are taken on a Wednesday or Thursday, because people are going to interview somewhere else, and don't want to say, oh yeah, I want to take a vacation next Wednesday. They just make up some story about terrible diarrhea they have or something. I went over there and interviewed, and I was really impressed with the team. They had some of their interview questions were completely impossible, which I loved, and I learned a ton. And then others were just, only difficult. And I think the only reason I got the job was I had recently interviewed at Google as well, and they asked a lot of the same questions in both interviews. So I managed to get a few of them right. Anyway, point of all this is I ended up going to work for them, and one of those, there we go. Okay, great. It was run by a really brilliant CTO, and he was Eric Ries. And what the company was doing was trying to apply this sort of new philosophy to software product development of having an agile process applied to this product where you're constantly learning and constantly shipping. And it worked out pretty well except for a few things, and that's what I want to talk about, where this process falls down. So this business process hinges on being able to do continuous integration. Okay, and most of you know that means that you're constantly just integrating new features into the mainline branch and shipping it to customers. So the idea is you can get actually feedback from the market very quickly by continuously integrating. And the reason it's called lean is that you're eliminating a form of inventory. So the lean startup is an idea that comes from lean manufacturing, sort of a movement in the 80s in US manufacturing based on manufacturing techniques developed in Japan in the 60s, especially Toyota. And the idea is that by doing sort of a lot of just-in-time supply techniques, you eliminate a lot of the inventory that you have around the manufacturing process, and that reduces your total capital outlay. You end up being able to manufacture with a lot less money and a lot less overhead than you otherwise would. Similarly, in software, if you're constantly shipping code, you don't have these features sitting there waiting to be shipped to customers. And it just means you can run a lot more efficiently and deliver value that much more quickly. So that's sort of that whole lean idea. And the other part, as many Agile developers know, it just makes engineers a lot happier because they're constantly shipping code to customers and they're not waiting around for 6 months or several years in order to see their code live in production somewhere. So the key to continuous integration and making that work comes down to tests. So as you all probably know, after 2 days of the test track, we got a number of types of tests. You got unit tests to cover your individual functions and modules, and then you've got functional integration tests to test things at a little bit of a higher level. MU actually did something really interesting. So MU is the name of the 3D avatar chat company. They had sort of an immune system for online services. So the server cluster itself, when you delivered new code, would test the CPU and memory levels after applying the code to a few nodes. And if the levels weren't too high, then it would proceed to roll out the code to more and more nodes. And if something seemed out of whack, it would automatically reject the new code and go back to the old code, which I think is a very, very good technique that other people would benefit from. I think an immune system is a great name for it. We actually didn't have that name. I saw it for the first time when I read this book, but it's a good phrase and a good technique that I think more people should use. But I'm not going to talk about that today. All right, continuous integration. Well, and you know the old saw about theory and practice for computer scientists. The theory of continuous integration is you have this nice test suite. It covers everything. And before committing any new code, you run the test suite. In practice, as you get a large team and as the team grows, you get dozens of engineers, you get hundreds of engineers, and the total size of the code base is just growing and growing. Turns out people just run a few tests that seem relevant to the code that they're changing, and then they'll commit. So it ends up being this really ad hoc process that has all kinds of problems because people will end up breaking things without realizing it because they didn't run the whole test suite. Most people I talk to, seems to be some equilibrium out there of test suites running about 3 or 4 hours. And people will put in engineering resources into improving the test process until they can get it down to about 3 or 4 hours. So they'll buy a build farm, they'll buy lots of hardware, and then it'll grow to 5 or 6 hours, and they'll put some engineers on to try to reduce it. But in my view, 3 to 4 hours is still much too long. So yeah, again, the theory with continuous integration is you can deliver several features several times per day. We were often doing that at MView, but that would be on a good day. On a bad day, you just break the build several times per day. Finally, one last bit of the continuous integration theory is that you don't need QA. You'll just cover everything with tests. And that was also just not true in practice. We still needed professional QA to make sure everything was okay. So the problem all came down to the fact that our functional tests were too slow. Unit tests usually ran okay, but when it came to actually testing out individual web pages, you have these multi-step workflows, they would just get slower and slower and slower as the code base grew. So why are they slow? Usually it's a few reasons. One is you got a lot of repeated logic. You just keep, if you've got a multi-step workflow, you'll do the same thing many times across the course of many tests. The other reason that often comes up is UI code tends to be especially slow. You often have drawing going on with inside a web browser for sort of desktop development. This comes up a lot. Even if you just do HTML, generating that is fairly slow. Things tend to be acceptable from a web browser's perspective or for a user's perspective of loading in 100 milliseconds, but if you have to do that hundreds or thousands of times in the course of a test suite, it's just intolerable. Incidentally, so, well, I'll talk about HTML more in a little bit here. And the other thing is also has to do with GUIs, is there are all sorts of weird things with event loops like timeouts, and if you've done browser tests with Selenium, there are little things you have to do to make it work, and they just tend to slow down the process. So Erlang's a nice solution for a lot of these, or it can help out with a lot of these. Of course, Erlang doesn't have any drawing libraries, so the UI slowness is not a problem in Erlang. Yeah. Yeah, as for generating HTML, I talked about this a little bit in a talk I gave to the San Francisco Erlang factory. But making heavy use of IO lists and binaries, or especially binaries that are shared across multiple requests, can make HTML generation much faster than in other languages, which tend to concatenate a lot of strings together and have terrible cache hit ratios. Whereas Erlang can kind of recycle memory a lot when it's building up this IO list. So generating HTML is very fast. That's one of the things that initially drew me to Erlang. It just says event loops are slow. It says don't use JavaScript. And I kind of joked about it just in the slide here, but in practice I found it's just a lot easier to test simple, dynamically server-side generated HTML than complex JavaScript interactions. So JavaScript and one-page websites are kind of all the rage in web development now. But even though they're cool and designers like them, when it comes to testing them out, they're a real pain because you got to actually fire up all these browsers. You got all these event loop problems, and it ends up just taking much more time than running some tests on statically generated HTML or even dynamically generated HTML, where you're just trying to search the DOM for certain characteristics or certain information. So the main problem I'm going to address today is that of cutting down on repeated logic. Even though I think it's worth keeping in mind, especially these shared binary techniques, is probably the first thing you should do if you're doing a web test framework and want to cut down your time. You'll probably get the most gains from that, but this is sort of the most generally applicable. So the solution is deep dish, which I will be explaining. All right, so let's say you got a workflow. It could be like a user sign-up page or anything, where you got multiple little choice nodes. So either they do one thing and say they cancel, and you want to test something about that, or they do, or they go to the next step. And maybe they could cancel there, or maybe they go to the next step. Or maybe they cancel there, or maybe they go to the next step. Now, if you want to test this workflow, usually you say, all right, I'm going to have here's my first test case. The user comes in, they say no, and they cancel. I'll write a test case for that. Say, all right, I want to write another test case. Maybe now, the first step, instead of saying no, they say yeah, and they go here, and then they cancel. So now here's my second test case. And now I have a third test case where I'm going to go all the way down here and then cancel. And then I got a final test case where I go all the way to the end to the blue box and finish. So what do we notice about these tests? Well, your workflow, okay. If your workflow is, of order n, then your total test logic and testing time is order n squared, right? You got this like triangle square getting built up because you're going through the first step every time, and you're going through the second step every time except for the first. So that's really a source of unnecessary pain in these test frameworks, or in this test logic. And you can see it in the code itself. So if you have sort of one function that does something and then asserts something, it works okay if your workflow only has one step. But once you have 2 steps, you kind of add another thing in there, and 3 steps, you're adding another line of code, and then if it's a 4-step workflow, you got some more setup, and then you got more setup, and more setup, and more setup. So this thing just gets longer and longer. So not only is the running time n squared, but your code size gets to be n squared, because you got to have a separate little test function for each of these possible bailout spots in the workflow. Is that making sense? All right. So that's the problem I want to address.
So why do you write them and rather than generating them?
So these are typically, these will just be like trying to test something on web pages. And you're looking very confused. But it'll typically just be download this page and click on this button, and then you want to click on this button, and then you want to test something about something in the output there.
Yeah, it seems to me very automatable.
Are you thinking like quick check models or what? Yeah, okay. I'm not sure exactly how you would automate that. I think you could. Are you thinking of doing sort of like a table-driven test with things that you'd click, or I don't know how to automate this. Like all the time I spent writing tests at MVU, this is the best we could do is just do this, do this, do this. But so I'm not sure without being more specific about.
It seems to me a very simple thing to enumerate all the subsequences of.
Well, there's a lot of states, like in a database, all kinds of places. So how would you model that? You tend to automate it.
What do you mean?
Yeah, no, and the state is the main thing I want to talk about. Yeah, you've got all kinds of side effects here and there. I don't know. Let me go through this and then we can talk about it.
In the argument that you pass around.
Not if it's a database, not if it's a file system, and.
The pointer to the database.
Okay, we'll talk about it more. Well, let me get through this, and then we'll talk about that. Is that okay? You look.
Absolutely.
Okay. Okay. All right. So I just want to deal with this problem in particular. Here's some delicious Chicago deep dish pizza from Giordano's. So the main idea is it has to do with the state and how we're going to maintain the state, dealing as we go through the workflow. So the main idea is that any stateful resource that we have should exist as a stack. And anytime we want to go down, before we're going down one path of the workflow, we're going to do a push operation, which will copy the current state and push it onto the top of the stack. And then once we're done testing that branch and we want to go back in time, instead of going all the way back to Eden and recreating all of our test models and all of our setup logic, we'll just hop back and go back to our save point, basically. So that will just pop the current state off of the top of the stack, and then we can continue to go forward. So I got a little fake animation here with my slides. So you got like your first step here that you go through, you run a test, you say, okay, I want to go to the second, now I'm going to cancel out, and I'm going to run a test on that. And now I'm going to pop that state off of my stack, and then I'm going to do something else, and then proceed. So you're going to do this for all of your stateful resources. So as you kind of go through the test suite, instead of climbing up this tree every single time, you're just popping the state off of the top and going forward. And then you want to go all the way back, and you just pop all these off and go down a different testing path. Does that make sense? Okay, so that's the key. It's a very simple idea, but that's the entire gist of what I'm trying to get more people to adopt here. And I want to explain how to do this with various stateful resources that you might encounter, because it's really easy. So here are the implementations of this stack of state. So if you have a gen server, it couldn't be any easier. So you just have like a push operation and a pop operation. And instead of having a single state variable, you just have a list of all the states. So to push, you got your state and your old state, and then you just add a copy to the front. And the reason I love Erlang is that if this thing is, 10 megabytes, your copy isn't actually copying 10 megabytes. The data is immutable, so that's just always going to be a constant time operation. Similarly, the pop, all you do is discard the topmost state and then get back to business. And then when you yes?
Sorry, this is only provided you don't send this somewhere.
You don't send this somewhere. What do you mean?
If you use it in a message, this will explode.
What are we using in a message?
The second argument there.
Yeah, this is. I'm not sure what you mean. Because this is just the second argument to the gen servers. It's just the internal state maintained by the gen server. Okay. Yeah. I'm not. I'll get back. We'll have a long talk once I get through this. Okay. So then when you're modifying your actual gen server arguments, all the other ones, instead of having the single state argument, you access the state by pulling it out of this list of states. That's all you have to do to go from a regular gen server to sort of this stack-based gen server. Similarly, if you're doing an integration test with the SQL database, you can take advantage of save points and rollbacks. So this is the exact same idea with the save point. You say, all right, I've gone through this workflow to a certain amount. I want to save where I am, then I want to do some stuff, and then I want to basically hit undo and roll back to my save point. So in this way, so it's, desktop environment, you got undo and redo operations. Sorry about the sun here, hard to see that. But that's really all you have to do. When you're sort of creating a test framework around this, you've got all your resources receiving these push and pop operations, and it's just got to do an undo, it's just got to do a save point, a rollback, and then you're good to go. File system, sort of similar idea is if instead of sort of copying the entire file system, you can do something similar to what Erlang does and sort of treating it as immutable. But if you use hard links, you can create kind of shallow copies and then sort of do a copy on write if you actually want to modify something. So here I've got a little file system that's supposed to be like a user directory and a bin directory with 3 files in them each. For my modification, when I start out, I'll just have a hard link to the base directory so I don't actually have to copy everything. And then when I want to actually modify something in there, I can make an actual separate directory, then hard link the internals, and then create a copy of what I want to modify, and then modify it. So this is how a lot of backup systems work. So for example, Apple's Time Machine uses hard links in this way. So you have this whole history of your hard drive contained in relatively little space. And so you can use the same techniques if your service relies on the file system, or you maintain state in your application using the file system. So next I want to just talk a little bit about designing an API using these pushes and pops and stacks. Sort of the most obvious way to do it, this is just sort of pseudocode or pseudo Erlang, would be to do a push and pop around each step whose side effects you want to ignore. And that's a lot of graphics programming looks like this. I don't know if any of you have done graphics programming. You usually save your graphics context, do something, and then restore your graphics context. It's the exact same idea. but doing that for all your stateful resources. So here I cancel, but then I undo it, then I continue, then I save, then I cancel, then I undo it, and I can go forward that way. So that's sort of the most obvious way to do it. Another API you might use would be a little more functional, where you have some kind of transaction function that'll take a fun and then sort of implicitly perform the push before the fun's executed, and then pop afterwards. So that's one way to look a little bit nicer than explicitly writing push and pop after every one. So you don't have to worry as much about syncing up your pushes and pops and making sure you get the same number and all that. Finally, there's the API that I've decided to use with this deep dish module, and that is a recursive API. And the way the recursive API works is it'll take two arguments, an assertions argument and a continuations argument. These are both functions. So the assertions are functions about something that should be true about the output. So it's, sort of the core of your test. And then the continuations are going to execute code inside of the push and pop. So sort of similar to the previous design that we saw. But it's constructed in a way that we can sort of nest these together. And you'll see what I mean in a second here. So here's an example of the sort of example code of this dish module. It's hard to see, but I'll explain what's up here. First, it's going to do something. So it's dish do. It's going to perform a get request. And then we've got, as the next argument, we've got a set of assertions, and we have the continuations. So the assertion says, all right, we're going to get an HTTP OK from this. That's one thing we want to be true. And then we want the content type to be text HTML. So those are two very basic tests we can perform on the output. And then once that's done, if all that looks good, then we move on to these continuations, which in this module we use these named tuples, or sort of this prop list thing. Just to give them a name, we say we're going to click on the login, and we're going to take the result of the last operation, or of this get request, and pass it to a fun that will then do something else. So in this case, I'm going to say follow link that's named login. And the API design is the exact same as this get request. So if the slide were bigger, I would put assertions in here about the result of my follow link request, and then I would have a list of continuations for things to do after I've logged in. So I want to, it might be click on my messages, or so typically we'd have check HTTP OK, and then click on this, click on that, and continue forward with the test. So that's sort of a basic example of how this would work in practice. I like it because the test code ends up being relatively nice and clean. As you see, I don't have to repeat myself, as in the sort of the Simon Says code that I showed you earlier. You can just keep pushing forward in your workflow without building up all this sort of testing setup cruft. Yes?
Very, very disturbing. So how do you pop the click login state? I mean, so because presumably that changed state on the server side. Okay, now you're logged in, so you don't get logged out just because you pop a state in a gen server, right?
Yes. I mean, if the login state is in the gen server, then you would. After you, so this is performed inside the push pop. Yeah, yeah. Or you just, or while you're while you're running the test, you broadcast it to all stateful resources. So yeah, so that's the idea. Yeah. So if I added a test, sort of after the click login, it would be something else. I forgot my click I forgot my password, which would execute without being logged in.
Does it mean that you have to modify all your existing get servers to fit this pattern?
Yes.
So you're basically writing code that's only useful for running tests, or. But no, I mean, it also does other stuff, but like all this whole stack that you're building up everywhere, it's only useful for those tests.
Yes, that's right. But as I showed you, let's see, go back. It's not a complex modification you have to make. Probably do
No, but there's other stuff, like if you cache, like, do process dictionary stuff, and you would have to find
Yeah.
mechanisms.
Yeah, so,
all
yeah,
the
process
of your
dictionaries would,
application depends on your test model. Isn't that a bit like the other way around?
yeah, I mean, sort of the alternative, the other thing that people use is just writing, like mock services for lots of things where they basically recreate all the functionality. So this seems like a relatively low price to pay for that. But it is a set of costs and benefits. If your tests don't take a lot of time to run, and you're kind of happy, or you don't have too complex of workflows, or you're happy with the complexity of the test code, then yeah, it might make more sense just to keep doing what you're doing. So yeah, this is definitely, it does have costs in terms of implementations, for sure. Any other questions before I move on? Yes?
You can just knock out the GenServer model, essentially, and have all the graphical state pushing and popping inside GenServer.
Okay, that's what
That
that would do?
The one novel thing here is that you're actually designing the code to be tested, right? But
Yeah.
since it's already going through the framework of the Gen server, so that would be even more elegant actually to modify the Gen server.
Yeah, you could have a Gen server testable or
Yeah.
something, behavior testable. That's a great idea.
The whole state of the
Yeah, you'd lose, yeah. No, that would absolutely be possible. And that's sort of that's essentially the same idea with snapshotting or save pointing a database. Yeah, so it's all engineering trade-offs and how much time that's going to take.
The main purpose of this is to make the test suite run faster.
And the test suite be simpler and run faster. Yes. So just to give you an idea about the implementation of this previous GET request slide, it's pretty simple what this does. It kind of does something. This is get the page, and then it'll run these assertions, and then it does this push. Then it runs a list of continuations, and then it does the pop. So it's sort of what I explained just a second ago. And in reality, you would want to accumulate the number of failures and the number of successes, and then report those to the user somehow. So this is just sort of the state of the module as we have it now. It's a really small module. It really does not do much, but it does get requests, post requests, follow a link in the web page you downloaded, follow a redirect that you receive. I don't even know what this is. Oh, submit a form, find something. You can actually find a tag with a certain text inside the web page you download. It uses like the Mochi Web HTML parser. And finally, you can search for an email that was received. So it's the Gen service that we have. We actually have this mock email inbox that follows the same pattern. So you can check the inbox for, if somebody creates an account, you send out a welcome to our website email. You can check that, and then you can do the undo as if it were never sent. So that's what we have in the API right now. And then I just have one slide to kind of summarize the asymptotic characteristics of all these different considerations. Sort of the thin crust testing model, which is what everybody else does, and then this deep dish paradigm. So N is the length of the workflow. There are basically no benefits to this if you only have one-step workflows throughout your application. But if you do have a complex thing, the runtime is going to be N squared. Under thin crust, it's going to be order N. That's what we saw at the beginning. Skip down here, same with the code size. It's going to be N squared versus N. The space required, it's going to depend on the nature of your state that you have to maintain. Creating those copies is going to take up more memory. If it is Erlang terms, or if you're using sort of the hard link system that I described with the file system, it's going to be around, if the total memory required for a single snapshot of the state is M, you're going to have roughly M times N length of the workflow times the log of m. And the reason for that is if you're making one modification way down in this tree, you need to sort of save almost like the crumb trail going back to the root of things that were modified and leave the rest of the tree unmodified, if that makes sense. Does that make sense to people? Okay. So that's sort of a big O approximation for your space requirements under that pattern. If it's something like snapshotting the VM, if you use another pattern, it could be sort of worst case is n times m. Finally, one of the drawbacks is you may notice the scope level is starting to creep to the right in the previous slide. So if you have inline functions for your continuations, your scope is going to keep moving over to the right. A better pattern would be to actually create separate functions that you call for each of those, which will prevent that. But if you don't, and just write tests like I do, you've got this scope level increasing in order n, which is the length of the workflow. So you might want to buy a wider monitor. Yeah, so how are we doing on time? 2 or 3 minutes more? Okay. Yeah, do we have any questions then? Any more? Yes?
I'm still trying to wrap my head around this. It seems interesting. Could it possibly be used for like other use cases? I'm thinking like a RESTful interface testing, like ish stuff.
Yeah. So I've done this sort of in the context of a website, but I think anything that has multi-step workflows with state, you can apply the pattern to. Absolutely.
So the boring part is that the code has to be written in order to be deep dish testable, right? But
yes.
This modification to the Gen server, it's a fantastic idea to have an additional argument in the Gen server. It's obvious it should be there.
Yeah.
It will cost absolutely nothing, and it's almost zero code to Gen server, right?
You just add a push and a
Exactly. Exactly. So those will be generic APIs to the gen column push.
Yeah, that'd be great.
If we stack, you could have named checkpoints.
Yeah, name checkpoints.
Oh, yeah.
Even better.
So inside
Yeah.
the answer, we got a dictionary of named checkpoints.
Yeah, I'll send you a pull request. Yes.
Yes, you referred to an organization where the continuous integration was not working, in particular because running long test suites was too long.
Yes.
Do you see an application where this kind of solution increased the speed and so the continuous integration started to work again?
Yeah, I mean, just my own experience, the testing time for each test, like an MView, would be on the order of hundreds of milliseconds. So like you're doing a little like small test suite, it's going to be 5 to 10 seconds or 20 seconds or something. Sort of combining these techniques with the other benefits of Erlang, like with HTML generation, typically we can run dozens of tests per second. So it's at least sort of a 10 times speed up in that respect. But that's not, it really depends on the complexity of the workflow. So there's this algorithmic improvement that you get from complex workflows, and then there's kind of the constant time, C out front that you get from having Erlang just being faster at generating HTML. So it really depends on the application, what kind of benefit you'd see. Yes?
Perhaps this is the scope level right on the screen now, but how well do you find that you can pinpoint where the error occurs? I mean, if I have just one test case, that's one thing, and then there's mistakes, I know what's fake.
Yes.
But in this scenario,
Yeah, this will tell you exactly what test failed. So, and the way it works is with these sort of tags here. You got a tag, so you know the position, and it'll say test number, assertion number, whatever, inside of the click login, save point, essentially. Yeah, so you can pinpoint it that way. Yes.
I was thinking, I have been working some places where there was this continuous integration program, and it could be very interesting to have it, your solution integrated into Redbar. So we can run the unit test in that way. And with this Redbar routing, we can make sure we don't adhere the purity of the real production cloud, because we can in some way override the gen server function.
Okay. Only in the test
testing,
environment, right. Right, yeah, that's a good idea. Okay, that's it. Yep, thank you.